In this video demonstration, I will try to show you what happens when the earthquake waves, which consist of two types of waves, pass through sand. It's called liquefaction of sand. What happens during earthquake is actually earthquake waves consist of two kinds of waves, S wave and P waves. S waves are transversal waves. Their motion can be side to side or up and down in vertical direction or from horizontal direction. They tend to move the land like sideways or upwards and downwards. P waves, they are longitudinal waves and they move in the form of compression and rarefaction. So they kind of like compress the land at some points and expand the land at some points. So usually the earthquake waves, they are actually a combination of these two. That's why it's really deadly for the buildings and stuff. P wave will arrive first and that's usually followed by S wave. I will try to recreate the situation and we will see what happens to the sand when it is put in the same conditions as that. For what I've done here is I've tried to create the vibrations, but it's not exactly these two waves, it's just the vibration, but it will do the trick. It's called liquefaction of sand because what happens is the sand usually behaves like a solid. So when you're going to shake it very fast with high intensity, you will see that the sand tends to behave like a liquid, and that's what we're going to see right now. Okay, first let me explain what the setup is here. This is the source, this is the supply current, and it's going to pass through this makeshift vibrator. What's actually in this vibrator is that we have a motor here, a DC motor, with this unbalanced rotor kind of thing attached to it. When it will rotate, it will make the whole thing unbalanced and it will start to shake because of that. And in here we have sand in this bucket, and what I'm going to do, I'm going to use these three kinds of materials. One is a ping pong ball that is definitely lighter than sand, and then is this weight that is definitely heavier than sand, and this one here is the marble, which should be about the same density as sand. And we will see what happens to all these three things when sand becomes liquid. So let me just put this one here first. I'm going to put this ping pong ball inside it so that effect becomes more demonstrable. Just 1 second. Okay, so here's what I've done. The ping pong ball is right in there. I buried it right underneath the sand, and here is the marble. I can put it on top of the sand or I can bury it, so I'll just bury it for now. And here's the weight. I'm going to put it on top of the sand and see what happens to all these three things with different density than the sand when sand actually becomes liquid. I'm going to just start the vibrator first, safety first, try to stay away from it. Nothing happens because the vibration is not really that much. I'm going to increase the voltage. Now, see what happens. The ping pong ball came right up. The weight has started to sink, although it's not really clear right now because the vibrations are not that much. And we don't really know what happened to the marble. So we'll get to find out. I'll just increase the vibrations. The weight has been buried and the marble has started to come up. The reason that it came up is because its density is almost same as that of sand. Okay, so this proves that the things that are actually having the same density as the liquid that they are in, they come up, and this thing that has less density as that of the liquid, in this case that's the sand, it comes up. This has the same density as the liquid, or in this case the sand, it comes up, this marble. But the weight that has more density, because it's steel, has buried itself pretty deep inside the sand, so I will dig it out later. Point is that it sank because its density was pretty high. Okay, this is what happens to sand when intense high frequency vibrations are passing through it. Thank you.